First thing we discuss is that I want to visualize a qubit. The first thing I need to understand is how do I describe the qubit? And we say that a qubit belongs to the C2 space, right? It is a two-dimensional space with complex number. To fully describe this qubit, I need to know two complex numbers, alpha and beta. And the basis states are 0 and 1. I have alpha part of 0 and beta part of 1 that give me one particular state. But alpha and beta, they are just complex numbers. Complex numbers has 2 degrees of freedom. I need to specify the real part and the imaginary part to fix the complex number. On the other hand, also can say that for any complex number is equal to its magnitude times a phase, e to the power I delta a, right? Delta a is one number, one parameter, right? Phase is the angle, right? You draw on the complex plane, you have the magnitude and also the angle that give you a complex number, right? So as a result, we say that you actually need 4 degrees of freedom, 4 parameters to fix one complex number. This is not new to you, right? Because in the past, you want to fix one complex number, you need 2 degrees of freedom. You know that already, right? So to fix a state, a 1 qubit state, it has a 4 degrees of freedom. In this case, it's alpha, beta, and actually I have a typo here. It should be the magnitude of alpha and magnitude of beta instead of alpha and beta, right? But however, we know that alpha squared plus beta squared must be equal to 1 because we are talking about the qubit. It's not a general complex number, right? So once I know alpha, I should know beta. Or I should say once I know the magnitude of alpha, I should know the magnitude of the beta. So it reduced to only 3 degrees of freedom. I only need 3 parameters to specify 1 qubit state. Okay? Now, if they sum to be 1, then without loss of generality, I can just assume that alpha equal to cosine theta divided by 2 and sine beta equal to sine theta divided by 2. Because this square of cosine plus square of sine equal to 1. Okay? And of course, I need to take out a phase, right? But that is combined later to other place. But in summary, I can say that my word function here, actually, I combine the phase to here already, is equal to cosine theta divided by 2 times e to the power I delta alpha 0 plus sine theta divided by 2 beta e to the power I delta beta. Right? 3 degrees of freedom. Is this okay? And I want to further simplify it. This is a pretty complicated math, but what I'm trying to do is just take out a common part of alpha, and delta beta. Then I get e to the power I delta alpha plus delta beta divided by 2. Just a number, I call it gamma, right? And because I take out this one will become negative delta beta minus delta alpha divided by 2. I call it phi divided by 2. And this part becomes phi divided by 2. This is minus, this is plus. Okay? But after all, what I'm doing is here, you just can go through the math yourself. After all, what I'm trying to say that psi is just equal to a global phase. What is a global phase? This is the phase common to both bases, e to the power I gamma, times cosine theta divided by 2 times e to the power minus I phi divided by 2, 0, plus sine theta divided by 2 e to the power I phi divided by 2. You see, those inside is completely described by just 2 parameters. One is theta and one is phi. If I know theta, I know phi, I can describe those inside the square bracket, correct? Now, of course, to describe the states, I also need to tell people what is the gamma. But however, gamma is the global phase. We say global phase really doesn't matter physically. It has no physical meaning. Why? For example, the expectation value of a state for an operator M is given by this sandwich operation, right? The bra of psi times M times the k. And remember, what is this if you put in the matrix form? What is this psi here in matrix form? is a what? Is a what type of vector in matrix form? Column or row? Right? It's just a column vector, right? Like this. And then how about M? What is M? M is a matrix, right? And then how about the bra of psi? Is a row vector, right? And that gives you a number. Try that, right? It gives you a number, which is the expectation value. Now, let's say if the global phase is important, then I multiply the global phase in front of the psi, right? If you think that psi and e to the power I gamma psi are different, now I find the expectation value of this guy. Again, expectation value is I have this matrix and then multiply by the cat of this guy, right? Which is e to the power I gamma psi. How about the bra version of this one? Well, the bra of psi, but the complex conjugate of e to the power I gamma, right? That's what we learned in the Hilbert space earlier, right? But this becomes negative because it's complex conjugate. These two are just number. I can swap with m and that got cancelled, become 1. The result is the same. This just to prove to you one's case that the global phase is really doesn't matter. Okay? So because of this, we say, it's okay, I don't want to tell people, describe this function by gamma. I just describe by the 2 degrees of freedom, which is the theta and phi. It basically tells me the most important thing about this 1 qubit state. But remember, we did not really fully describe it. We only to describe it with the theta and phi. Okay? It's not a complete description, but it's enough if we want to use it to calculate any physical significant quantities. Now I have 2 degrees of freedom. Then I can put it on a sphere, on the surface of a sphere, not on a sphere, but on the surface of sphere. Because this surface of the sphere has 2 degrees of freedom. Okay? And in particularly, you see that if I put this sphere and embed it in the real 3D space, then it becomes very interesting because the theta turned out to be correspond to the polar angle of this sphere, and the phi turned out to be the azimuthal angle of this sphere. And that is why this Bloch sphere is so useful. But we always remind ourselves, the qubit does not reside in the 3D space. It resides in the space we cannot see, which is a 2-dimensional complex space. But we know that it is normalized, so we reduce 1 degree of freedom. We also know that we don't care about the phase. It becomes 2 degrees of freedom. Then we map it to this sphere. Think about how people draw the map. It was a sphere on the Earth. They map it to a 2D plane, right? That is a mapping. Our Earth does not live on the plane on our table, right? We map it. That is a simple mapping, easy to understand. This mapping is what? We are think about this. If we are 2D creatures, right? We're 2D creature. We cannot understand what is sphere. And some people try to map the Earth. Earth surface is in 3D space. And you try to map to 2D. And then so that I can understand what does our Earth look like. It's just like this. I am a creature, do not understand the 2D complex space. But now I map it to the surface of a sphere in the 3D space I live in, right? But again, here I'm missing the global phase. It's not a complete description. Make sense? And the interesting thing is that the theta and phi has some important correspondence to the physics we are going to measure. We will see that later. But just always remind yourself, they are not mapped to the same place. Okay? So because of this, then we look at some extrema on the Bloch sphere, right? We say, how about look at this point, the North Pole. What does it correspond to? Okay, North Pole has theta equal to what? 0. How about phi? Anything, right? So let's pick theta equal to 0, phi equal to 0. Then we know that the psi is equal to this equation, right? So I put theta equal to 0, cosine 0, of course, is 1. Phi is 0, so this e to the power 0. Sine 0 is 0. Then this becomes 0. So the North Pole corresponds to the basis state 0. Again, it doesn't mean that the 0 resides on the North Pole. It just resides when we map it to this Bloch sphere. And then someone came to us, right? Last time, someone said, what if phi is not 0? Okay, let's put in phi is not 0. Then sine 0 is still 0. This term is gone. But this cosine 0 is 1. We still need to have e to the power negative c over 2i. Then you have e to the power negative c over 2i 0. And it's still at the North Pole, right? Because by definition, theta equal to 0. So it means that at the same point on Bloch sphere, you can map to many different quantum states. However, they are only different by a global phase. Why is that? Because we make the assumption at the beginning already. We say, I don't care about the global phase. So that's why you end up with two states mapping to the same point with different global phase. Okay? Yeah, question?
That was a question last lecture.
No. Maybe this is what.
Again, not equals.
No. See this, right? So you're asking how is this global phase related to this global phase? This is different. This is a general state. Every state I can factorize out a global phase so that I can get this to negative phi over 2 and phi over 2. Right? This is a general phase. Here is saying that what if I have a state like this? You look at this, because this is 0, right? So this one can be a global phase of 0 and 1, right? I can write this as e to the power negative c over 2 I 0 plus 0 times 1, right? This is still a global phase to the whole thing. That's what you mean by global phase here. But what I want to try to say is, let's do not talk about global phase. Maybe I'm not accurate. Their difference is only by a phase. That is more accurate. This one and this one only different by a phase. They are different states, but only different by a phase. Like this one. This one and this one only different by a phase. And that's why they have the same physical meaning. Yeah.
So when you do a measurement, the point low phase is gone.
It's gone because when you do a measurement, you are going to have the complex conjugate with it, right? If you only, is there any computer? How about you tell me? Is there any way we can measure or feel the effect of the phase? We have done the algorithm so far, right? Shor's algorithm, Deutsch algorithm, quantum phase estimation. Did we feel the effect of the phase? You use it for interference. We did feel the effect of the phase. We feel it because it is not a global phase. It's the different phase between different qubit and state, right? So if it is a global phase of the whole system, you either bring in another system that have different phase, then you can feel it. If this is the only system that you have, then you cannot feel it. If you only have one qubit, you have the global phase, you really cannot feel that phase. Bring in another qubit where you know the phase, then you do some interference. Then you know what is the phase of the first one. Yeah, good question.
So, global phase
Well, no, Bloch sphere is just used to map map the points to some state, and for each point, for those states mapped to the same point, their only difference is by the global phase, by a global phase. But there's no relationship between phase between different point of the Bloch sphere. For example, this point, it mapped to 0. It also mapped to anything e to the power something I times 0, because they all have the same state, except their difference is by a phase.
Because we're with two different qubits, couldn't gamma be such that
We only have one qubit here. Each Bloch sphere is only one qubit. 0 and 1 belongs to one qubit. A superposition of a qubit is not two qubits.
well, I was talking first qubit.
The first state, I would say first qubit state is 0. Second qubit state is phi e to the power something 0. Yes? Okay.
If the phases
Yeah, they have different phase. We don't know whether they are we cannot distinguish them by physical measurement. Yes? That's what the same question, right? Can we distinguish these two states by using some measurement? We cannot, unless we introduce another qubit to do interference. Okay. And then we look at another, yes.
Just like you gave the example of the room and how you get
Say again?
just like
Yeah. Uh-huh. Yeah.
it.
No, because when you make the Earth into 2D, you actually distorted the Earth, right? Yeah, you can do some mapping, but or I would say is meaningless. Why do you want to put this into 2D? The math is more complicated, right? You try to map the surface of a sphere to 2D is a more complicated math. It would be easier to do it here. Yeah. Okay, then let's look at another extrema, right? Let's look at this. How about pi, theta equal to pi divided by 2, and then the phi equal to 0, right? Some of you already know this is plus because you saw that, but let's plug in cosine pi over 4, e to the power negative 0 divided by 2, right? So this is 1 over square root 2, 1 over square root 2, this is 1, so you get the plus. Okay, let's try one more example. I want you to be very familiar with this. What if theta equal to pi over 2, phi equal to 0? Sorry, I mean phi equal to pi over 2. Just by looking at the Bloch sphere, what is that? 0 plus I1 divided by square root 2. This is the eigenvalue of what? Do you remember? Sigma y. Okay, we will see that later, right? But let's just do it. We say that the psi equals to cosine. What is theta? Pi over 2. So it becomes pi over 4 because it's theta divided by 2. E to the power negative I. What is phi? Pi over 2, right? And then phi over 2, it becomes pi over 4 also. And then 0 plus sine pi over 4, e to the power I, pi over 4, 1. Okay? This is a little bit messy, but I'm going to take out a common factor to help my make it easier. Let me take a look. I look at my cheat sheet. I'm going to take out the e to the power I pi over 4. Right? This is just a pure math manipulation, right? So what will you get? First one is cosine pi over 4. Huh? Forgot? 1 over square root 2, yes. So I take out I pi over 4, so this becomes e to the power negative I pi over 2, right? Because negative pi over 2 plus pi over 4 give me pi over 4, negative pi over 4, right? And then how about the other one? What is e to the power? This becomes what? E to the power I pi over 4, take out e to the power I pi over 4, it becomes? Huh? This one, take it out, what do you get? Yeah, just one. Is that okay? What is e to the power I pi over 2? Cosine pi over 2, and then plus I sine pi over 2. Yeah, I, right? So, and then how about e to the power I pi over 4? We need to do it. I do it here, okay? E to the power I pi over 4 equal to cosine pi over 4 plus I sine pi over 4. What is that? I might did something wrong here. 1 over square root 2 plus I 1 over square root 2, right? But I don't care about this actually. I don't want to add this to my face. It's ugly. Yeah. How do I factorize this? Yeah, I take out this and this becomes negative I pi over 2. This one becomes 1, right? You just multiply. And actually, I don't need to calculate this. Because I just look at this one. This gives me e to the power I pi over 2 times 1 over square root 2 times why I would
Isn't it the negative?
yeah, you will fix it, but I will continue because I did not nothing wrong, right? So far for the math. Nothing wrong, right? So I will put let's say how about this negative I? Then this becomes negative I. Okay? So this becomes 1 over square root 2 times, but you're right, I need to go to that one so that I can fix it. So sorry everyone, my mistake. I will keep this one. My cheat sheet has problem. So I'm going to do this. I know this is, instead of taking out the I pi over 4, I'm going to take out negative I pi over 4. Okay, like what you said. Then this term is gone. All right, let me do it again. Sorry for that. E to the power I pi over 2, 1. Okay, so let me show you what I'm doing again. I take out e to the power negative I pi over 4. Then this becomes 1, right? And this one becomes I pi over 2, right? Because pi over 2 minus pi over 4 equal to pi over 4. Is this okay? And then for this part, I will keep this negative, right? And then the cosines and sine 1 over square root, I take it out. This becomes 0 plus what? This is I, right? Is that okay? You see that what I'm doing is not exactly the same as this one, but it has a face, which is this one. I can ignore it actually, because as I said, every point on the Bloch sphere corresponds to the states different by a global phase. So yes, I get this one because there are infinite number of states correspond to this point, right? Now I just want to take one that is clean to me, just clean to human being, easy to read. For human being, this is easy. So that's why I picked this one. Okay? Is this clear? Of course, I can do something, right? Add a phase, multiply by I pi over 2, then this will be gone. Right? Because I have the rights to change the phase. So just now, although I take out e to the power I pi over 4 is ugly, but at the same time, I can factorize it later also to get the same thing. But of course, it's not good in the class. It's very lengthy, right? So you're right, I should have done that. Right? So are you okay with the Bloch sphere now? Right? The most important thing, I don't think many textbook or tutorial would talk about this. They will just, everyone just think that this point is correct, correspond to 0. And later they will run into problem when we do the rotation. That is the first thing. Second thing is that the north and south is not in the real space, right? 0 plus 1, if they are really in the real space, should be nothing. But here 0 plus 1 is actually plus. Make sense? Remember this. Okay, the first reason, why do we want to use Bloch sphere? It is very useful because we can use it to correlate to the physical quantity we want to study. First of all, I ask you, what is the expectation value of the sigma c? Means the spin in the z direction. In the z direction, what is the expectation value if I give you a state psi? We just mentioned, how do you find the expectation value? Ra, what is the matrix for the spin? Sigma z. This is how we find the expectation value, right? What does it mean? It means I try to measure it many times. I should get that value on average, right? This time I get 1, next time you only get 1 or 0, right? Whenever you measure the spin, correct? It always collapses to the basis state, but you get 0 and 1, and on average it's different. But what is this average? Let's take a look. What is psi again? Yeah, but I want to use what I derived earlier, cosine theta over 2, e to the power, is it negative? I phi over 2, 0, plus sine theta over 2, e to the power I phi over 2, 1, right? How do you write in the column form? Yeah, cosine theta divided by 2 e to the power I negative phi over 2. Okay? I hope this is simple to you. We have emphasized this a lot in the previous video, right? E to the power I phi over 2. Is this okay? Because we know this corresponding to 0, this corresponding to 1. How about the Z matrix? What is that? Sigma Z. 1, 0, 0, minus 1. It's so easy, that easy, right? How about this Bloch form of the psi? I'm going to have a problem in writing. What is that? The same thing, psi theta divided by 2, e to the power what? Minus I theta over 2? Positive I, yes. I phi over 2. Okay, let me add a comma. Okay, we usually don't do that. Sine theta over 2. And then what is that? Negative I phi over 2, right? Then let's do the math. The rest is easy. Let's do the multiplication with the matrix and the cat first, right? So I copy the whole thing. What do I get? What do I get after the multiplication? For the second, the multiplication. This one multiply this one. Cosine theta over 2, e to the power, minus I phi over 2. Because times 1, right? This one is minus sine theta over 2 e to the power I phi over 2, right? Because we're doing this row times this column, 0 times cosine negative 1 times this one. I get a vector again. Matrix times vector makes sense because I'm rotating the vector. It should be a vector. And then multiply by this one, right? So I'm too lazy. I don't want to write it, but we can see now I'm multiplying this one with this one. How do you calculate this one? This term times this term, right? Which is cosine square theta divided by 2. I phi divided by 2 times negative I phi divided by 2. What is that? Equal to 1, right? Yeah. How about the second one? Sine square theta divided by 2. Same for the phi, right? Because this is negative, this is plus. Multiply becomes 1. What is sine square theta divided by 2 minus cosine square theta divided by 2 minus sine square theta by 2? You probably forgot, I forgot also, so I need to check the table. It is equals to cosine theta. Believe it or not, it is equal to cosine theta. Check the table, trigonometry table you learn in high school or middle school. Okay, I forgot.
Is that cosine?
Okay, so he is saying that cosine square theta turned out to be the magnitude of 0, right? Yeah. And sine square theta turned out to the magnitude of 1, right? Yeah. Pretty good. What is the magnitude of 0 represent? The probability. So this is saying the probability of getting 0 minus the probability of getting 1, right?
That makes sense.
Yeah, but this not really makes sense, but this related, you can derive it. But the point is this is so equal to cosine theta. Now look at this. What is cosine theta in this figure? Cosine theta in this figure is just the projection of your state onto the z-axis. That is cosine theta. So that is the great thing about this Bloch sphere. You know, I'm trying to measure the expectation value of the spin, right? So it should give me either 0 and 1, the average. And turn out it's the projection onto that axis, which makes sense, right? The expectation value of this plus minus on the equator, the expectation variable should be 0. Because half of the chance they will get 0. Half of the chance they will get 1. So that's why they have this. Sorry, I'm wrong. Let me go back to your question. Let me say again, I'm wrong. Okay. What is the eigenvalue of 0 state? Plus 1. Remember? Because this is 1. What is the eigenvalue? Yeah, it is minus 1, right? So now go back to this one. Isn't that the expectation value? Yeah, expectation value is going to be the probability of getting 0 times negative 1 plus probability of getting 1. No. Probability of getting 0 times 1 plus the probability of getting 1 times 1, right? Times minus 1, right? Because that is the eigenvalue. Right? Which is 0, P0 minus P1. Correct? The probability of getting eigenvalue of 0 is, the expectation value is the probability times the eigenvalue, right? I may get 0 or I might get negative 1, right? And so the probability of getting 0 state times its eigenvalue, which is plus 1, plus the probability of getting the one eigenstate, which has the eigenvalue -1, which is -1, right? Is this right? So this is P0 minus P1, right? And you just told me that P0 is cosine square theta divided by 2, because this is the coefficient. And P1 is sine square theta divided by 2, because this is the coefficient. It's talking about the probability of getting 1. After all, the square of this term is P0. The square of this term is P1, right? So you have a good insight. I was wrong because I keep thinking about 0. Okay? So everything makes sense. You see? The probability, what is the expectation value I will get for any state? It's just its projection on this axis. Yeah.
So we expect
Yeah, expectation is, yeah, that's a general. We actually used that before, right? Like in assignment 1, I asked you what is the expectation value. And I asked you to either use this equation, the regular equation, like what you just said, right? You give 1, 1, 1, 0, 1, 0, right? But the percentage is going to be following P1, right? So this don't mess up. I messed up. I keep thinking the eigenvalue of 0 is 0. No, it's 1, right? And eigenvalue of one state is -1. Because the matrix, right, this is diagonal, right? And then everything makes sense, right? So we use this formalism, we get cosine theta. Or we use this one, we also get cosine theta. And that makes sense as a Bloch sphere. That is the first reason you want to use Bloch sphere. Now you see that you even can imagine that the expectation value of getting plus and minus 1 along the x-axis is going to be the projection onto there. Okay, is this okay for this one? Let's do one more exercise. What is the expectation value on the sigma c on any state? How do you find it again? Sigma c, sorry, I said sigma x. What is the expectation value on sigma x? Just put what? Just put sigma x, right? So let's try to go through the math again, okay? What is x? Remember? 0, 1, 1, 0. What is the psi, right? Memorize it. What is that? Cosine theta over 2, and there's another, must be e, right? Negative I phi over 2, sine theta over 2, e I phi over 2. Okay, 2 parameter. You should be able to know that is 2 parameter. Even you cannot say it, it must be 2 parameter because we reduce from 4 degrees of freedom into 2. Okay. How about for the row form? Cosine theta over 2. E to the power, what? I phi over 2, right? Because complex conjugate. Sine theta over 2, e to the power, negative I phi over 2. Okay, so I do the same thing. Again, I'm lazy. I'm not going to write this. What do you get on the right? When you matrix multiply the vector, you get a vector. And what is that? Yeah, this is just a NOT gate, right? Swap them, right? So when you are doing something, always try to understand more. You realize that, this is just a NOT gate, and it help you to check your answer. Okay, then I multiply them. Now this is not so simple. I have cosine theta divided by 2 sine theta divided by 2 e to the power I phi. Make sense? And then plus, thank you, plus sine theta divided by 2 cosine theta divided by 2 e to the power negative I phi. Good. Complicated. But I can factorize it, right? This is equal to what? Cosine theta divided by 2 sine theta divided by 2 e to the power I phi plus e to the power negative I phi, right? What is this, the term in the parenthesis? E to the power theta, p to the power something plus e to the power negative something, I, becomes 2 times cosine theta. If those who cannot see it, look at this. E to the power IA plus e to the power negative IA equals to cosine A plus I sine A plus e cosine negative A, right? Plus I sine negative A. Do you see this? And then the sine got cancelled. Cosine theta A equal to cosine negative A equal to 2 cosine A, right? So this is what we have. You get cosine theta divided by 2, sine theta divided by 2, and then 2 cosine phi. What is 2 cosine theta divided by 2 sine theta divided by 2? Again, forgot, right? It's just a double angle equation, which is equal to sine theta. 2 sine theta cosine theta equal to sine 2 theta. Okay?
I was hoping the answer would be cosine phi, because that would be the projection along the x.
Is it cosine phi?
No, but then you also have a sine theta.
Let's see why. Let's see why. What is in this state, right? What is sine theta? This part is sine theta. You project to the equatorial plane first. This part is sine theta. Do you see that? Because this is theta. You first need to project this to here. Yeah? And then you project the cosine to the x-axis. Yeah? That's what you learn in, I don't know, spherical coordinates or whatever, right? So in D, you see that the expectation value of sigma x, you project to plus minus basis. Yeah.
So this just happens to be such that we're at 0 plus I1 square root 2 is and 0 minus.
Is that okay? But here just to show you that, see, the projection is just actually the real 3D space projection. It will give you the expectation value, right? That's why it's useful to use Bloch sphere. Rotation? You can say that you try to change the basis, yeah. You can say that, yeah. But let's don't do so complicated. The point is, like, look at the projection, right? Yeah, you can do many things to test your knowledge by doing rotation. That is great. Now, how about let's do something even more? Oh, not yet. I still want to try more example, actually. How about the expectation value on y? Now, let's do it a little bit quickly. I think I have this in the assignment. Right? I just want to show you what it is. Now here I try to make it simple. I don't want to write the whole thing, right? I just assume the psi equal to A0 plus B1, but I already know what is A, what is B, right? Then this is easier. I want to do it faster. 0, negative I, 0, AB. Do you agree? So what do you get? A star, B star, negative IB, IA, right? Which is equal to negative IA star B plus IAB star. Okay, then I now do the substitution. This is equal to negative I, and what is A? A star is cosine theta divided by 2 e to the power I phi divided by 2. Right? This is A star. And B is sine theta divided by 2 e to the power negative e to the power I phi divided by 2, right? This is B. And do the same thing here. A is cosine theta divided by 2 e to the power negative I phi divided by 2. And then B star is sine theta divided by 2 e to the power negative I phi divided by 2. Okay? So the first one is negative I cosine theta divided by 2 sine theta divided by 2. I take everything out. Maybe I don't do that yet. E to the power I phi plus I sine theta divided by 2 cosine theta divided by 2 e to the power negative I phi, right? Up to here. Because this is just sine theta divided by 2 cosine theta divided by 2, and this becomes negative. I add them together, right? And then I need to factorize them. A little bit troublesome. Cosine theta divided by 2 sine theta divided by 2, I will put the I out. Then what do I get? I get negative E I phi plus e to the power negative I phi. Okay, because here I take out I and this whole term, so it's negative E I phi and e to the power negative I phi. So what is this? This is cosine plus I sine, but it's negative. This is cosine minus I sine, right? So cosine got cancelled. And then I have minus 2I sine, right? So this is equals to minus I square cosine theta divided by 2 sine theta divided by 2 sine phi. Okay. So just follow what we did before. I square is negative 1, right? So this is, I'm missing the 2, right? So this is just equal to cosine theta sine phi. So it's the same as the last one. We first project to here to get the cosine, oh, is it cosine theta? This is sine theta, I'm sorry. Sine theta, yes. Because 2 sine cosine equal to sine, right? Sine 2 theta. So this is just equal to what? Sine theta. And then you project to here, to the y. Okay? So this is just repeat. I go through it fast because of time. Try to understand it by yourself. I think I did not do this in the last semester. Okay? Now, I do want to talk about Pauli vector. We spent some time on Pauli vector. Pauli vector is actually very important if you want to go to higher level. Or even in the future EE274 quantum computing architecture, you use a lot of Pauli vector. Because the Bloch sphere now it becomes very useful. It basically is useless before in the algorithm. We don't need to know Bloch sphere. But now you do the physical qubit, you need to know the Bloch sphere. Because you realize that this is not just for spin. I can map the superconducting qubit. I can map the trapped ion qubit. They all based on different physics to this Bloch sphere. So I can have an effective magnetic field in superconducting qubit. That is not the magnetic field, not the real effective magnetic field you have in the Josephson junction. It's just the effective field help you to map to the Bloch sphere, right? So Bloch sphere becomes very important. And then this Pauli vector is, of course, very important. Do you remember what is Pauli vector again? N dot sigma. Do you remember? We say you even can have a vector that has the Pauli matrix as the coefficient, right? What is N? Nx, Ny, Nc, right? It's a unit vector in the space, maybe this one. Maybe this one, right? This is N. Okay, I want to know what is the expectation value if we measure along this arbitrary vector. It means I put the magnetic field in that direction, right? So that's, and what do you guess? What would be the expectation value? Again, projection of the Bloch sphere states on that point. Right? That's the good thing about Bloch sphere. Again, I tell you that this state does not reside in our real space. But I move into the Bloch sphere, when I do the measurement, I do get the expectation value as the projection along that line. Okay? And Bloch, and it's basically saying that the observable is what? Sigma x, sigma y, sigma z, right? This is the observable of the spin matrix in that direction. That is the Pauli vector, right? We discussed in the previous video also, right? At that time, you don't know what we're talking about. Now, let's see if this is the case. If I try to find its expectation value, of course, I need to again follow this form. I hope you feel comfortable with this. In the past, you should be very nervous when you see this, but now it's nothing. This is just the matrix, the observable. The matrix corresponds to the observable, right? Just an operator, a matrix, applied to a vector, and this is the Bloch version. And this is the FH value, or the expectation value you will get when you perform experiment on this observable. This is daunting, yes, but we also agree that it's nothing because someone proved to us that the spin or the operator along the n direction is just equal to this. And we are very comfortable because this is number, this is number, this is number, but this is matrix, which is okay. We say that we are happy if you have a complex coefficient for a vector. We are also happy when you have a matrix as the coefficient of a vector, right? Remember this thing? What is this thing? This is just a laughable, right? You may even say, oh, this is sigma x times x hat plus sigma y times y hat plus sigma z times z hat. X, y hat, z hat are in the real space. And x is what? 0, 1, 1, 0 is a matrix. We are happy with that. We are comfortable with that, right? So what is this? All I need to do, just expand it. This becomes x times sigma plus xy sigma y plus nz sigma z. Make sense? Because it is nothing but just the dot products, right, of two vectors. They all have the same basis. The bases are the real dimensional bases, right? But because quantum mechanics is linear, so this is equal to what? Nx sigma x ny sigma y nz sigma z. Do you agree with what I'm doing here? Huh? Do you agree? Just distribution law, right? And this is number, I take it out, right? And what are these? These are just the expectation value we already just learned. It is equal to nx times cosine theta psi phi. Is it? Or cosine phi, I forgot. Sine theta cosine phi, sorry. Sine theta cosine phi plus ny sine theta psi phi plus nz cosine theta, right? But what is this? Isn't that this is just equal to nx ny nz dot product with sine theta cosine phi, sine theta psi phi, and cosine theta, right? But what are these? This is just n. The first one is just the n itself, right? What is the second one? Second one is just the vector, the unit vector of psi. This vector in real 3D space. Okay? I'm not talking about the qubit state. I'm talking about this vector correspond to the qubit state. And this is just what? Projection. projection of vector of 3D vector psi on N. Yeah? I don't expect you to do this in your exam, but I really hope you can appreciate every piece of information here, because if you can appreciate, you are really good now. You are very comfortable about this operation now. You can read many articles without problem. Okay? And appreciate the beauty here, okay? Any questions? Okay, so that's what we will talk about Bloch sphere for now, right? But more importantly, the second reason to Bloch sphere is that we can visualize how a quantum gate works on Bloch sphere. But again, you need to be very careful because it's going to be very dangerous if you don't do it right. First of all, you all need to trust me. Any quantum gate, again, what is that? It tries to rotate the vector, the two-dimensional vector in the C2 space, right? If I rotate in that space, but that space is mapped to my Bloch sphere, isn't that is the same as rotating on the Bloch sphere? Right? I'm rotating the real quantum qubits in the C2 space that I cannot see. But I already mapped that space onto the surface of the Bloch sphere. So if I'm rotating there, I'm moving there, it's like I'm moving here, right? And moving here is just like rotating in the 3D space, right? Looks like. And that is the good thing about Bloch sphere. Any quantum gate can be represented by this U, 3 parameter, theta, phi, gamma equals to cosine theta divided by 2 e to the power negative, negative e to the power I lambda sine theta divided by 2 e to the power I phi sine theta divided by 2 e to the power I lambda plus phi cosine theta divided by 2. Very long and very messy. You can check my textbook. Just copy from there. Any gate I can describe as the rotation of 3 parameters. And this is called Euler angle. Euler's angle. Okay? So what does it mean? When you see a gate, not gate or whatever, I can map to here. Okay? It has 3 parameters, theta, phi, lambda. What does it do? I'm saying here. This is real 3D space. This is a Bloch sphere. When you apply this gate to a state, it rotates on the embedded Bloch sphere by this. First, about the z-axis by lambda. And then rotates about the y-axis by theta. Okay, in this direction. I hope that I did not do it wrong. Yeah. And then rotate again about the z on this third direction. 3 steps. And it corresponds to this matrix. You can check, right? This, you can prove it, but you just take it for granted here. Okay? So let's just try it, then try to fill it. This is the matrix I just said, right? Let's try to construct a NOT gate. What does it mean? It means, what do I want to do? I want to make cosine theta divided by 2 I e to the power I lambda sine theta divided by 2 e to the power I phi sine theta divided by 2 e to the power I lambda plus phi cosine theta divided by 2 equals to what? 0, 1, 1, 0. If I can choose theta, phi, and gamma such that this matrix equals 0, 1, 1, 0, then this is a NOT gate. And because I understand what is the meaning of theta, lambda, and phi, I know how I should rotate in the Bloch sphere in order to get a NOT gate. And you will find that it is not just rotating. You will think that, let me just rotate from North Pole to South Pole, then it's a NOT gate. No. Because this is a special case, I will show you why that is wrong, right? But let's do this first. How do I solve this equation? Cosine theta equal to 0. So theta equal to what? Pi over 2. Right? So, oh, you're too fast. So now then we want this one. E to the power I phi sine theta over 2 equal to 1, right? But we already have theta equal to pi over, no, I'm wrong. Pi, theta equal to pi, right? Not pi over 2. Because pi over 2 equal to, yeah. Is that okay? Yeah. So now I already pi over 2 sine pi over 2 equal to 1. Then what should be the value of phi? 0 is a possible solution, right? Okay. So if this is the case, then I need to think about, how about the top right term, right? E to the power I lambda sine theta divided by 2. I want it to be 1. And now the pi is pi over 2, which is good, right? But then, how can I make this equal to 1? You don't see the minus sign here?
I hadn't noticed it before.
Okay, before, okay. Lambda needs to equal to what? If you don't have minus signs, lambda equal to 0, right? Now you have minus signs, lambda equal to pi, right? Because cosine pi is 0 plus I sine. No. Cosine pi is negative 1, right? And sine pi is 0. So this one gives you 1, right? And then how about the last one? Let's check if this is correct. E to the power I, what is lambda? Pi plus 0 cosine pi over 2. What is cosine pi over 2? 0, which is correct. Okay? So a NOT gate is this. Not that simple. Lambda equal to pi. It's not just theta equal to pi. Okay, let's take a look. What does it mean? First, you need to rotate about this by pi. Okay? And then you rotate about the y-axis by pi because theta equal to 2. And then do nothing. Third rotation is 0. And that's what I did in the IBM Q. I have this general gate, pi, 0 pi. Pi, the first pi is theta. The second pi is the phi. The last pi is lambda. Just because of the notation, it's very confusing. Pi, phi, pi, that's how you write it. However, the first rotation is actually lambda, not the last one. Okay? Just watch out for the notation. Okay? I do this. What do? I input 0 and then a NOT gate. What is this after the NOT gate? 1. And pi o pi, pi 0 pi is a NOT gate, right? So it should give me 0. I input 1 and then a NOT gate. It should give me 0. Is that right? So I should, yeah, this is identity, right? Let me do it again. Q1 is 0. Yes, this is the first bit. Oh, I said I input 1, so I'm sorry. I say it wrong. I'm sorry. Yeah. Right? So what should I get? 1 0. That is what I get. 1 0. Okay? Yes, you need to do in this order because this is the theory. We prove that any gate, if you want to use this matrix, is based on this order. No, because we have this order and then we derive this matrix. Yeah, otherwise, what is the meaning of theta? It must come from a definition first, right? What is the meaning of lambda, right? So this is the so-called Euler rotation. But be careful, there are different types of Euler rotation. Look at my book, I say there's intrinsic, extrinsic. I also don't know it well. Just be careful when you map it to other Euler rotation, okay? But just be careful. But in this textbook, and generally, we use this one. I think this is the same. If you go to IBM Qiskit textbook, they also use this matrix. Just check it carefully, okay? Be very careful because people have different notation, okay? That now I want to tell you why Bloch sphere is not complete. Bloch sphere dump the face. Now, what if you say, I know Bloch sphere, why I need to go through the math? I feel that NOT gate is just rotating pi, like here, rotating about the y-axis by pi. Do you? Looks okay, right? Because if I rotating about y-axis by pi, it flips 0 to 1, and it flips 1 to 0, right? But think about this. How about plus state? When I apply a NOT gate to plus states, what do you get? 0 plus 1, you do the NOT gate equal to 1 plus 0, which is just, no more NOT. Make sense? Yeah, I ignore the normalization. Yeah. Remember, NOT gate is just a phase shift gate, right? In the plus minus basis, right? So yeah, it's still plus, correct? Now if I still have 1 minute. So if I look at this, if I only say this is the NOT gate, right? What does it do? It actually brings me to the plus, correct? Now, if I use the real one, the first thing here, NOT gate, rotate by how much? Pi, lambda. So it brings me to minus. And then second rotation theta by pi, it brings me back to plus. Third rotation, do nothing, plus. This is correct. So you cannot try to construct a gate by using the Bloch sphere with a special vector, special data. It's very easy to make mistake. And when I begin learning quantum computing, I always will get confused. Isn't that is so simple? Why it is not? It does not. It does not fit the result, right? Does not match the result. It's just because Bloch sphere has something get omitted, which is the phase. So you can go, it can help you to visualize it and then help you to design the gates. But you cannot design it directly by just looking at the rotation of the Bloch sphere. Okay? So that's all I want to say today. Thank you.